Presentation on the PIX firewall in regards to inbound access, meaning access from the outside world into the PIX, into your internal company network. That's what we call it, inbound access. In the first lab we did outbound access, where through a NAT relationship your inbound hosts were allowed outbound access to internet resources, etc., based on NAT statements. And the magic to all this, remember, is the security levels. It is the interfaces each have a security level. The inside interface has a higher security level than the outside interface, and therefore traffic is permitted freely to flow from the inside to the outside because the inside has a higher security level. So when it goes into the PIX, it establishes a state table for that particular TCP or UDP session and connection, and the return traffic is allowed to come back because that session has been established properly. Now, coming from the outside in, that's not true. You can't just initiate traffic from the outside to in, even if you knew, for instance, the internal host's mapped NAT address. You could not do that because the PIX will not allow traffic sessions to be initiated from a lower security level interface to a higher security level interface. So traffic cannot flow from the outside interface through the inside interface by default. The only way to do that is to create an access list, which is what we're going to work on. And that's important because if we have services, particularly in the DMZ, we're going to need to have a way for the PIX to allow that traffic. Excuse me. So an access list is going to be the way we do that. So the two methods of allowing traffic to pass are network access or network address translation and access control. NAT works generally from the inside out, and we require access control to work from the outside in. Although we will also still require a NAT relationship so that a live address appears to the world. And we're going to get in to that in just a moment. From ACL usage guidelines, again, higher to lower security level is the default behavior. You're going to be able to allow that traffic anytime by default out of the box. If you do not want to allow higher security level traffic to go through the lower security level interfaces by default, you wanted some user not to have some particular access, let's say, you would need an ACL for that as well. So ACLs can be used on the internal interfaces as well, but we typically are going to put our ACLs on our outside interface. At least for this class, for simplicity's sake, that's what we're going to do. We're going to fall into the lower item here, lower to higher security level. So we're going to use an ACL to restrict the inbound traffic. Now, that's a little bit of a misnomer. The inbound traffic is already restricted. In fact, it's restricted to 0 initially. So we're going to have to actually use an ACL to punch holes and allow traffic from the outside in. So some syntax is going to come up in a moment, but the ACL destination address, when we're determining where traffic can go as a destination, we're talking about the NATed global IP address. So if we have a server on the inside that presents itself to the outside world as 192.168.1.3, and again, that's a private address, I'm aware. We just tend to use that particular range to represent public addresses in this class. If we're using that address as a public address, that is going to be the destination address inside the ACL, and we'll see that when we get to it. We will need a statically mapped address for internal destination addresses. Dynamic addresses would cause problems. It's going to require static. And we're going to apply it at the lower interface, and in our case usually called outbound or outside. We're going to apply it at the outside interface in an inbound direction. So it's from the perspective of a little guy sitting inside the firewall. Let's take it that way. If we apply the ACL in a inbound direction, in other words, we say ACL outside interface inbound, then we mean it's coming inside to the PIX from the outside. We're going to show some examples of all this if I'm confusing you. This is just some syntax on the access list. It's much like a Cisco access list if you've had that. Notice that the syntax down below at the config prompt here, access list, that means we're getting ready to create an access list. We're going to call it DMZ1. That's what DMZ1 means there. It's the name of the list. And what this particular first statement is going to do is it's going to deny TCP traffic from the 192.168.0 subnet to the host 192.168.0.1 if the port is less than 1024. Now it's just, it's just the syntax of the command. We're not going to get heavily into the syntax of PIX ACLs. I just want to give you an example of one, how to read it, and that's basically how to read the access list. And we're going to write some as well. And again, I'm going to show you an example in a minute of the one you're going to do in the lab. Once we write an access list, we need to apply the access list. And we apply the access list with the access group command. So the access-group DMZ in, that means we're going to apply it in an inbound fashion to the interface called DMZ. So this binds the ACL DMZ1 to interface DMZ. That's all this command does. Now, to make any of this work, for our inbound connections, we're typically going to need two things. We're going to need an access control list, and we're going to need a NAT statement. And the NAT statement is going to be a static NAT statement. Last time you did a dynamic NAT statement. This time we need to do a static NAT statement. So to make a static NAT statement, if you'll look down at the diagram below, we see that we want to make this DNS server from the internal network have a presence on the external network, and we wanted to use the address 192.168.0.18. So if we want our internal DNS server that's at 10.0.0.10 to present itself to the outside world as 192.168.0.18 all the time, that's a static NAT translation. And here's the syntax in the PIX for that. It's static, and in the parentheses, the interfaces in question. In this case, it's the inside and the outside interfaces, and that's the flow. It's from internal to external in terms of a static NAT statement. So we go static, parenthesis, inside, outside, which in this case, that's what it's going to be. And then, of course, we flip it, because someone that wrote this iOS was crazy, and we use the global IP followed by the internal IP. So the global IP will be 192.168.0.18, and the internal IP will be 10.0.0.10. So one guy told me one time to remember it this way: inside, outside, outside, inside. So we go static, parentheses, inside, comma, outside, parenthesis, outside, inside. So the outside address is 192.168.0.18. The inside address is 10.0.0.10. That means traffic will be mapped if it comes in from the outside, destined for 192.168.0.18. It'll map it internally to that internal IP address, and people on the outside won't know that that mapping ever occurred. So we're going to need a static NAT statement, and we're going to need an ACL to make inbound traffic work. Here's another example of that static NAT statement. And again, notice static, inside, outside, outside, inside. And notice there's one other piece you have to put, a net mask. And that net mask is usually going to be 255, 255, 255. All right, here's an example. This is going to serve you well for your lab this week. Okay, we're going to create an access list that allows a remote desktop connection and Windows XP to another XP machine, except this XP machine is out on the internet, and now it's going to be connecting to an XP machine inside your network. And we're going to allow that for reasons just because we've decided to allow that. Let's just say it for now. And then next week we'll get into a little more advanced example of this. But on the out there on the internet somewhere is an XP box that's going to remote desktop into, let's say, that DNS machine there, and we're going to allow it by saying access list RDPN. That's our name of our access list, and we're going to permit TCP because the remote desktop protocol is TCP traffic. We're going to permit TCP from any source. That's what any means. Any source to host 192.168.1.3. That's specifically to a specific host for that DNS server. Now, previously to this, if we were going to use this example in reality like we would in the lab, we would need a static NAT statement that would map 10.0.0.10 to the 192.168.1.3 global address. And your lab will tell you how to do that. So we're going to permit TCP from any source to host 192.168.1.3 equaling 3389. That's RDP traffic because it runs on port 389. So we've specified that port traffic running on 3389 can go to 1.3 via this access list statement. Now our next statement in the access list says to deny IP any. So that's the only thing this access list is allowing is RDP to this particular host. And we've decided to allow it for some reason. Access group RDP in, that means inbound, that last in, applied to the interface outside. So the outside interface of the PIX is being applied, or it's going to have an access list applied to it in an inbound direction. And that's going to allow this traffic to work. Okay, so there's two things here. We need a NAT statement, we need an access list, and then we need to apply that access list to allow inbound traffic. That's what this week's lab's about. In the lab, it's going to tell you exactly how to do it. This is just some background on helping you to do it. If you have any questions, of course, email me, post them, whatever. And I'll be able to help you in the board or in class.